Suppose if you are having a 3 cross 3 matrix instead of 2 cross 2 matrix, if the key matrix is a 3 cross 3 matrix, then how to find out its corresponding inverse? So as I told, we have to find out the determinant first, and then we have to check whether we are going to get multiplicative inverse of the key matrix. So directly you enter the matrix in your calculator and find out the determinant. So here we are going to get the determinant as 23, determinant of K. And I need to find out multiplicative inverse. So for this, either I can go for extended Euclidean algorithm, or I can multiply 23 with other numbers and take mod 26. For whichever the number I'm going to get the remainder as 1, then that number will be the inverse. So here I'll going to use extended Euclidean algorithm. Okay. So when we are going to take the determinant from calculator directly, we are going to get the determinant as minus 939. For this, I need to take mod 26. As I told, when the number is large, you first divide 939 from 26. Okay, you forget about the sign first. First, you find out the remainder, and later subtract remainder from 26. So you are going to get the modulo. So when I'm going to divide 939 from 26, I'm going to get the remainder as 3. Since the remainder is 3, what I have to do? I need to subtract the remainder from 23. I'm going to get the corresponding modulo. So here we are going to get determinant of K is nothing but 23. That is minus 939 mod 26 is nothing but 23. So how to find out the multiplicative inverse? What I'm going to do is I'll take the extended Euclidean algorithm, and then I'll going to find out the multiplicative inverse. So here we are having Q, and then we are having A1, A2, A3, and then it is B1, B2, B3, and then it is R1, R2, and R3. So here A1 must be initialized to 1, A2 is 0, this is 26, that is modulo, and B1 must be initialized to 0, B2 for 1, and this is the number for which I want to find inverse. And then I need to perform 26 divided by 23 to find the quotient. So the quotient is 1, and the remainder R3, what I'm going to get is 3. And how to find R1? R1 is A1 minus B1 into Q. So we are going to get that value as 1, and R2 as minus 1. A2 minus B2 into Q. Since the remainder is not 0, repeat the process. That is 0, 1, 23. This will become the column A, and remainder will become column B, and repeat the process. So here we are going to get the corresponding quotient. 23 by 3 means the quotient is 7 and the remainder is 2. So again you find out the remainders R1 and R2. So this is minus 7 and this is 8. Since the remainder is not 0, once again repeat the process. So while repeating the process, this will become A, and this will become B, and find out the quotient. 3 divided by 2 is, quotient is 1 and the remainder is 1. So according to that, we are going to get R1 and R2 as minus 8 and sorry, 8 and minus 9. And one thing you have to observe carefully, whenever we are finding extended Euclidean algorithm, so here reminders R1 and R2, sign will be alternatively, sign will be keep on changing. In the first row, R2 will be negative, and in the second row, R1 will be negative, and in the third row, R2 will be negative. And also, if R1 is negative means R2 will be positive. If R2 is negative means R1 will be positive. This one we have to remember. Okay. If we are getting both the reminders as negative means we are doing a mistake. Okay. Since here the remainder what we have obtained is 1, the corresponding inverse is minus 9. So the inverse of 23 is minus 9 mod 26. So when we are going to get minus 9 mod 26 means we have to subtract 9 from 26 and we are going to get the value as 17. Okay, so 17 is the multiplicative inverse of 23. And now we have to find out the corresponding adjoint. So when we are going to consider adjoint of K, so first I'll determine the cofactor, that is cofactor of K transpose. So cofactor of K transpose. So here we are having K as 17, 17, 5, 21, 18, 21, 2, 2, 19, and its corresponding cofactor, sorry, K transpose. Okay, so K transpose is 17, 21, 2, and 17, 18, 2, and 5, 21, 19. So this is the K transpose, and for this I need to find out cofactor. So when we are going to consider cofactor of K transpose, we have to understand. So here the first row, first column means the sign will be positive, and I'm finding the cofactor of 17. So for cofactor of 17, I need to skip this row and this column. So what I'm going to get? I'm going to get a matrix. Okay, submatrix. Previously, when we consider 2 cross 2 matrix, I need to get only one element, but here I'm going to get a matrix. So whenever I'm going to get a matrix, what I have to do? I need to find determinant of this matrix. So here the cofactor of the first element, that is 17, will be the determinant of the matrix 2, 18, 2, 21, and 19. And similarly for the second element, the sign, that is minus 1 to the power of first row second column, that is minus 1 cube. So we are going to get minus 1, and here the element is 21. So I need to skip this row and this middle column I have to skip. So as a result, what we are going to do? We are going to consider the submatrix as determinant of submatrix 17, 2, 5, and 19. So when I'm going to skip the first row and middle column, I'll be left out with the elements 17 and 5. as well as 2 and 19. So according to that, they will form a submatrix, and I need to consider its determinant. And again, when I'm going to consider cofactor of the third element, so here the first row, third column, so I and j, 1 plus 3, that is 4. So I'm going to get positive, minus 1 to the power of 4 is plus. And cofactor of 2. So what I have to do? I need to skip the first row and last column. So when I skip the first row and last column, so I will be left out with the elements or submatrix 17, 18, 5 and 21. So accordingly, this submatrix I need to consider for determinant. Okay, like this, the process will going to continue. So for the second row, second element, what I have to do? I need to completely skip this row. Okay. And if I'm going to consider for 17, second row, first column means I is 2, j is 1. So 2 plus 1 is 3. Minus 1 to the power of 3 is minus. So I will be getting minus. And what are the submatrix? I need to skip first column and second row. So when I skip first column and second row, I will be getting 21, 2, and this is 21, 19. And similarly, second row, second column means I will be getting positive sign. And here, second row, second column I have to skip means I will be getting the elements as 17, 2, 5 and 19. And again, second row, third column means minus 1 to the power of 5. So we have to skip second row, third column. So the elements are 17, 21, 5, 21. And similarly here, I'll be getting third row, first column. So I is 3, j is 1. So minus 1 to the power of 4 is 1. So skip third row and first column. So we are going to get the submatrix as 21, 2, 18, 2. And similarly, third row, second column means the sign is negative, and the elements what I'm going to get is 17, 2, 17, 2. And here third row, third column. So 3 plus 3 is 6. So minus 1 to the power of 6 means plus. So we are going to get the elements as 17, 21, 17, 18 because I have skipped third row and third column. So now this will be the cofactor matrix. So find out the determinant and you are going to get the cofactor matrix. Okay. So when you find the determinant using the calculator, so we are going to get the values as 300, then minus 313 and 267, minus 357, 313 and minus 252, then 6, 0 and minus 51. So these are the elements of the cofactor matrix. Since they are out of range, take mod 26. So what matrix we are going to get here? We are going to get the matrix as 14, 25, 7, 7, 1, 8, 6, 0, 1. Okay, this is the cofactor matrix. And the inverse. So in order to find inverse, what we have to do? We have to multiply determinant of k and its multiplicative inverse must be multiplied with the cofactor matrix. That is 14, 25, 7, 7, 1, 8, then 6, 0, 1. Okay, if we multiply these two, I'll be getting K inverse. So multiplicative inverse of determinant of K, which we found out was 17. So here we can observe that we are having 17. So now I need to multiply 17 with this one. So I will be getting 17 into 14, 25, 7, 7, 1, 8, 6, 0, 1. And for the multiplicated matrix, I need to take mod 26. So finally, what I'm going to get? I'm going to get 4, 9, 15, and then 15, 7, 6, sorry, 17 and 6, 24, 0, and 17. So this is the K inverse what we are going to get. And in the first part, here I have taken the inverse matrix just for reference. So here we can observe that whatever we have found out and whatever it is given, both are same. So using this, we can able to perform encryption. So in order to do encryption, what we have to do? Previously, when we took key matrix as 2 cross 2 matrix, we had considered only 2 column and more number of rows. But when we are having 3 cross 3 matrix, what we have to do is we have to divide the message as 3 cross 3 column. That is plain text as P, A, Y, M, O, R, E, M, O, N, E, pay more money. Okay, like this we can write the matrix. Since it is a 3 cross 3 matrix, the number of columns must be equal to 3. And this should be multiplied with the matrix K. That is nothing but 17, 17, 5, and then 21, 18, 21, and 2, 2, 19. Okay. And here also, in order to use the calculator, we can divide this. We are not having 4 cross 3 dimension in the calculator. So what I can do? I can divide this as 2 cross 3 matrix, 2 submatrices, 2 cross 3 and 2 cross 3. So then what I'm going to do? First, I will multiply this submatrix with the key and I'm going to get a submatrix. Okay. And afterwards, I'll multiply the second submatrix with the key. So I'll be getting another submatrix. So if we perform this matrix multiplication and take mod 26, we will be getting the corresponding ciphertext as 17, 17, 11, 12, 22, 1, and then 10, 0, 18, and 15, 3, 7. So according to this, we have to write the corresponding ciphertext. Okay. So this is how we can able to perform. Similarly, in case of decryption also, you take this ciphertext matrix and multiply with K inverse. So we will be getting the decryption. Okay.